Hello dear friends, welcome to our tutorial videos, and as you can see we have chemistry, and the question or the topic that we'll be discussing is more concept specifically on calculating or finding limiting reactants or reagents. Okay, so the question is saying ammonia gas is manufactured in industry from hydrogen and nitrogen in the Haber process. Okay, there's actually a topic specifically on the Haber process, but here we'll just be discussing or finding ways of determining the limiting reactant. Okay, so the equation for the Haber process is hydrogen plus nitrogen giving ammonia gas. Okay, so given that 10.0 grams of hydrogen was reacted with 15.0 grams of nitrogen, what do they want? So the first question is write a balanced chemical equation for the reaction. Okay, so to write the balanced chemical equation, we are first of all going to write our equation, which is here. This is the chemical equation. Now they just want it to be balanced. And if possible, you even put state symbols. Okay, so coming back here, we write the equation. So solutions. Okay, so the first question, they want us to write the balanced chemical equation. So the equation is hydrogen, H2, plus nitrogen gives the ammonia gas, which is NH3. Okay, now they want us to balance this. Okay, so when we check, we have 3 hydrogens this side, we have 2 hydrogens this side, we have 2 nitrogens, we have 1 nitrogen. Okay, so when you are balancing chemical equation, never start or never try to balance hydrogen. Hydrogen balances itself, so you can start balancing anything else but not hydrogen. So let's balance nitrogen. So nitrogen 2, nitrogen 1. So we can put a 2 here. So remember, these numbers we put, we're just trying. So if we put 2 here, nitrogen will be 2, nitrogen 2. So nitrogen has balanced. Let us find out on hydrogen. Hydrogen is now 6. 2 times 3 is 6. We can now balance hydrogen. So first of all, always start with any other element before you balance hydrogen gas. So 2 times 3, that is 6 this side. So if we put 3 here, it means we have 3 times 2, we have 6 hydrogens. Even this side, we have 6 hydrogens. We have 2 nitrogens this side. Also this side, we have 2 nitrogens. Meaning that our equation has balanced. That is simple and straightforward. And putting state symbols, all of them are gases. So this is a gas. This is also a gas. And ammonia is also a gas. That is in the Haber process. That is the equation for the Haber process. Actually, this equation is reversible. So sometimes you, in other books, you find that they put another arrow there. Okay, so let us now proceed to the next question, which is the sole or the most important thing in this video is to help you understand how to determine the limiting reactant in the reaction. So the keyword is reactant. So when you are dealing with the limiting reactants, you just deal with the reactants. By this time, you must know that every equation has got the reactants on the left hand side and the product on the right hand side. So here they want us to determine the limiting reactant or reagent, meaning you just focus on the reactants. Okay, so what are the procedures for finding the limiting reactants? Okay, so let us now go on You got? So the second question is saying determine the limiting reactant in the reaction. So they want us to determine the limiting reactant. So the key word is the reactant. Okay? Limiting reactant. So meaning for you to determine the limiting reactant, you deal with the reactant in the equation or in the reaction. Okay, so of these two, hydrogen and nitrogen, which one is going to be the limiting reactant? Meaning that which one finishes faster as the reaction is going on or is taking place? Which one limits the continuity of the reaction? That is the question. Which one is depleted first? That is what it means by the limiting reactant. Now, for you to find the limiting reactant, the procedures are you find the number of moles of hydrogen and the number of moles of nitrogen, because these are the reactants that we have. On the right hand side, we have the product, so you don't deal with the products. Limiting reactants, meaning you just deal with the reactant. So let's find the number of moles of hydrogen and the number of moles of nitrogen. And then from there, we compare their mole ratios or divide these coefficients to find out which one is depleted or which one will have a lower number of moles. Okay, so let us do that. Let us do that. So using the next board. So now let us calculate the number of moles for each of the reactants. So let's start with hydrogen. So hydrogen is H2. Okay, let us calculate its number of moles. So number of moles is given by the formula mass over molar mass. Okay, this mass here, that is the mass given in the question. While molar mass, you calculate the molar mass using the mass number of the given element. So in this, the element is hydrogen. The mass number of hydrogen, is 1. So 1 times how many hydrogen molecules do we have? We have 2 hydrogen molecules. So you say 1, which is the mass number, times 2. The molar mass is therefore going to be 1 times 2, that is 2 grams per mole. Okay, so that is the molar mass. So the number of moles is therefore going to be the mass given. According to the question, they've said, given that 10.0 grams of hydrogen was reacted with 15.0 grams of nitrogen. So 10 grams of hydrogen, meaning the mass of hydrogen given is 10.0 grams. So we're going to use that as the mass. Okay, so the mass is 10.0 over molar mass is 2 grams per mole. So the number of moles of hydrogen are going to be 2 into 10.0. That is going to give us 5.0 moles. So that is the number of moles of hydrogen. Let us also calculate the number of moles of nitrogen. So nitrogen is N2. And according to the formula, number of moles is mass over molar mass. So in that question, the mass is 15.0 grams. Let us now find out the molar mass of nitrogen. So the molar mass of nitrogen, according to what we did here, molar mass is found by using the mass number of nitrogen times the number of nitrogen molecules. Okay, so molar mass is going to be mass of nitrogen, or mass number of nitrogen is 14 times How many nitrogen molecules? We have 2, so you say times 2. So molar mass of nitrogen is therefore going to be 14 times 2, it will give us 2080 grams per mole. Okay, so that is straightforward. Let me write this properly. 28 grams per mole. Okay, 28 grams per mole. Okay, so that is the molar mass of nitrogen. Therefore, the number of moles is going to be number of moles is equal to mass over molar mass. So the mass is 15.0 over molar mass is 28 grams per mole. And then when we divide 15 divided by 28, that is giving us number of moles is 0.54 0.54 moles. So that is the number of moles of nitrogen. Okay, so now that we've calculated the number of moles, what are we supposed to do? So let us now compare their mole ratios. So first of all, going back to the balanced chemical equation, the balanced chemical equation, hydrogen has a coefficient of 3, nitrogen has a coefficient of 1. So their mole ratios are 3 to 1. Okay, so the mole ratio is for hydrogen, so H2 to nitrogen. Hydrogen has 3, nitrogen has 1. The number of moles for hydrogen was 5.0. Then the number of moles for nitrogen is 0.54. So what you do is you get this number, you divide into this. You also get this number, you divide into this. So you are therefore going to say 5.0 divided by 3, 0.51 divided by 1. I mean 54, sorry, divided by 1. So 3 into 5.0, 3 into 5.0, so 5.0 divided by 3, it's giving us 1.67. To 1 into 0.54, it is giving us 0.54 for nitrogen, 0.54 for nitrogen. Now, when you compare these last numbers or values, you find that the one with the lower number is nitrogen, meaning nitrogen finishes faster than hydrogen, implying that nitrogen is the limiting reactant because it has got a lower number of moles compared to hydrogen. Okay, that is simple and straightforward. So first of all, you find the number of moles for each, and then using the balanced chemical equation, you get this number for hydrogen, you divide it into the number of moles for hydrogen that you found. You also get the number here, it means there is 1. So you get 1, you divide it into the number of moles for nitrogen, and then you compare the results. Comparing these, therefore, we can conclude that nitrogen is the limiting reactant. Okay, so watch the video as many times as you can and try out other questions, similar questions, and you'll find that finding or determining the limiting reactant is simple and straightforward. Thank you very much and stay blessed.